In this, we will be discussing about limiting reinforcement index or limiting percentage of steel. So in IS 456 2000, so Annexure G, that is page number 96, we have a formula for depth of neutral axis. So let me open the code. So IS 456 page number 96. See here, depth of neutral axis XU divided by D equals 0.87 Fy into AST divided by 0.36 FCK BD. So this is the equation for depth of neutral axis. So depth of neutral axis. So it is given by XU divided by D, which is equal to 0.87 Fy AST divided by 0.36 FCK BD. So call this as equation number 1. So rearrange the terms and simplify equation number 1. So I will cross multiply these two. So it can be simplified as XU multiplied by 0.36 FCK BD, which is equal to, so D into 0.87 Fy AST. So further it can be simplified as AST divided by BD equals 0.36 FCK XU divided by 0.87 Fy into D. Clear? So 0.36 divided by 0.87. So 0.36 divided by 0.87. So it will be 0.41379. So almost it is 0.414. So AST divided by BD equals, so it is almost 0.414 FCK XU divided by Fy into D. So it is equation number, call this as equation number 2. So from basics of RCC, we know the formula, percentage of steel PT equals AST divided by BD multiplied by 100. So this is the equation for percentage of steel. So it can be rewritten as AST divided by BD equals PT divided by 100. So call this as equation number 3. So now comparing comparing equation 3 and equation 2. So this is your equation number 2 and this is your equation number 3. So on comparing equation 2 and 3. So here from 2 and 3 the similar terms are AST divided by BD. Okay. So next we will further simplify it. So on comparing equation 2 and 3. So it can be written as PT divided by 100 equals 0.414 FCK XU divided by Fy into D. So further multiply these two. So PT Fy into D equals 100 into 0.414 FCK XU. PT Fy into D equals, so 100 multiplied by 0.414. So 100 multiplied by 0.414. So it is 41.4. So 41.4. Remaining terms are FCK into XU. So call this as equation number 2. Sorry, equation number 4. So we know that. At limiting moment, so percentage of steel PT, which is equivalent to PT limiting, and depth of neutral axis XU, it can be taken as XU max, maximum depth of neutral axis. So let me substitute these two terms in equation number 4. So your equation 4 becomes, so here PT, it has to be written as PT limiting Fy into D equals 41.4 FCK XU. XU can be written as XU max. So it can be further simplified as PT limiting divided by Fy, into Fy divided by FCK equals, so here remaining terms 41.4 into XU max divided by D. So here it is simple. I have taken this FCK here in the denominator, here depth of effective depth. So I have taken it as XU max by D. So this equation, you call it as equation number 5. So here in this equation, this ratio, limiting percentage of steel multiplied by Fy divided by FCK, it is called as, this ratio, it is called as limiting reinforcement index. This ratio, it is called as limiting reinforcement index. So next, from IS 456 2000, page number 70, or you can refer table B, page number 9 of SP16. For various grades of steel, you have XU max divided by D values. So for 250 grade, it is 0.53. So for 415, it is 0.48. For 500, it is 0.46. For 550, it is 0.44. And we remember, for 600 grade, I think it is 0.43. You just recall this from previous video. So let me substitute these values in equation number. So what is the above equation? Equation number 5. So let me write the equation number 5 once again. So it is limiting percentage of steel multiplied by grade of steel Fy divided by grade of concrete FCK equals 41.4 into XU max divided by D. So this is your equation number 4. In this equation, I will substitute XU max by D values. So first, so for 250 grade, so this equation will be PT limiting multiplied by Fy divided by FCK equals 41.4 multiplied by, for 250 grade, what is the XU max by D value? It is 0.53. So it is 0.53. So if you simplify this, so 41.4 multiplied by 0.53. So it is 21.942. So similarly for 415, so Fy equals 415. So on left hand side, you have same equation. So here equals 41.4 multiplied by, for Fy 415, XU max by D value, it is 0.48. So it is 0.48. So let me simplify this. .4 multiplied by 0.48. So it is 19.872. So similarly for 500 grade steel. So on the left hand side you have same equation equals 41.4 into, for 500 grade XU max by D value it is 0.46. It is 0.46. So 41.4 into 0.46. So it is 19.04. So 19.044. Next, similarly for 550. So it will be 41.4 into, so for 550 grade XU max by D value it is 0.44. 0.44, which is equal to, so 41.4 into 0.44. So it is 18.216. 18.216. Okay. We have evaluated the limiting reinforcement index for various grades of steel. So these values are readily available in table C of SP16 on page number 10. So let me open the code. So SP16 page number 10. See here. So this is your table C, limiting moment of resistance and reinforcement index for singly reinforced rectangular sections. So for 250 grade it is 21.97. For 415 this ratio, limiting percentage of steel multiplied by Fy divided by FCK ratio, it is 19.82. For 500 grade it is 18.87. We have similar values. For example, if we have grade of concrete as M20 and grade of steel as 500. So for this case you can evaluate the limiting percentage of reinforcement. So first note down the equation for 500 grade. So equation is PT limiting multiplied by Fy divided by FCK equals, so for 500 grade what is the value? 19.044. So it is 19.044. I am using this equation. So here PT limiting multiplied by Fy, grade of steel, it is 500 divided by FCK, grade of concrete, it is 20, equals 19.044. So first solve this. 500 divided by 20. So 500 divided by 20. So it is 25. So PT percentage of limiting steel multiplied by 500 divided by 20, it is 25 equals 19.044. So here limiting percentage of steel, which is equal to 19.044 divided by 25. So let me solve this. 19.044 divided by 25. So it will be 0.76. So limiting percentage of steel, it is 0.76. So which means whenever you are using M20 grade concrete and Fe 500 steel, so this is the maximum percentage of steel it has to be used. So 0.76. Yes, here. This also available in table E of SP16. Maximum percentage of tensile reinforcement PT limit for singly reinforced rectangular sections. What is the calculated answer? So whenever we use M20 grade and Fe 500 steel, what is the optimum percentage? 0.76. So let me check the code. So here you have a grade of concrete 20 and here you have grade of steel 500. So what is the limiting percentage? It is 0.76. So calculated answer is also 0.76 percentage. So similarly, we can check the maximum percentage of tensile reinforcement for various grades of steel and various grades of concrete.